So what happens when we divide powers that have the same base? So for example, 2 to the power of 5 divided by 2 to the power of 2. Well, so similar to what we did in the previous video, let's expand each of these powers. So 2 to the power of 5 is the same as 2 times 2 times 2 times 2 times 2. And 2 to the power of 2 is the same as 2 times 2, right? And a way that we can rewrite this is we can split this fraction, right? So this is the same as 2 over 2 times 2 over 2 times 2 times 2 times 2, right? Or you can imagine that they're a little, these 2's are just 2 over 1, 2 over 1, 2 over 1. And the reason why I say these are the same is, remember, to multiply fractions, you multiply all the numerators together and you multiply all the denominators together. So if you were to do that, you would get back this fraction, 2 times 2 times 2 times 2 times 2 at the top, and at the bottom you would get 2 times 2 times 1 times 1 times 1, which is just 2 times 2. So this is exactly the same as that over there. And the reason why I've separated them like this is so that, we can have this kind of cancelling effect. 2 divided by 2 is the same as 1. And 2 divided by 2 is the same as 1. So effectively what you're left with is 1 times 1 times 2 times 2 times 2. And so your answer there is 2 to the power of 3, right? So 2 to the power of 5 divided by 2 to the power of 2 gives you 2 to the power of 3. So what's happened is that this 2 has cancelled with the 2 over there, this 2 has cancelled with the 2 over there, and all I'm left with now is 2 to the power of 3. So let's use this idea to simplify the division of two powers that are much larger. So obviously we're not going to be writing out 75 threes being multiplied together, and likewise we're not going to be writing out 58 threes being multiplied together. We want to use the idea of what we saw in the previous example to help us figure out the value of this quotient, right? The value of this division operation, the output of this division operation. So if we imagine that we expanded this power, we would have 75 threes being multiplied together at the top, and we'd have 58 of them at the bottom, which means that 58 of these 58 threes, would cancel with 58 threes here at the top. And so what would be left? What we'd be left with is 3 times 3 times 3 times 3 times 3, 75 minus 58 of them, right? Because 58 of them will have been cancelled. So what we're left with is 3 to the power of 17, right? There's only 17 threes left being multiplied at the top. And so in general, if you have a to the m divided by a to the n, which can also be represented as a to the m over a to the n, that's just equal to a to the m minus n. What we mean is if you have some m of some number being multiplied together and you divide that with n of some number being multiplied together, then n of those a's are going to cancel with some of the a's up here, and what's going to be left is the difference between those two. So a to the power of m minus n. So let's apply this quickly to some example. So say we needed to simplify that. Well, so you've got 12 a's being multiplied at the top, multiplied together, and 4 at the bottom. So the 4 at the bottom are going to cancel with 4 of the ones at the top, and you're going to be left with 8 of them. So 12 minus 4 is 8. You're left with 8 a's being multiplied together. And similarly over here, you've got 9 b's being multiplied together and 6 of them at the bottom. So the 6 at the bottom are going to cancel with 6 of the ones at the top, and you're going to be left with b to the 9 minus 6, which is 3. And that would be your final answer.